All right, so we're going to talk about key features of quadratic functions. Now, there are more than this, but we're going to just focus on these three today. And in the next video, we're going to do a few more. So first, the y-intercept. We should know this by now. Our y-intercept is the number that is not attached to a variable. So whatever number that is, that's going to be where it crosses the y-axis. So we have this coordinate point, 0, 16. Now, if you just put the y-intercept as 16, that's fine. I know what you're talking about. But technically, it's the coordinate point 0, 16. So at 16, graph's going to cross the y-axis. Now, max and min, you kind of know this intuitively, but we've never really mentioned it. Because a is negative, that means this graph is going to open down, right? We're going to have this N-shaped graph. So that means that we're going to have a point of our vertex that's going to be the highest point the graph will ever reach. So because it's the highest point the graph will ever reach, then here we have what's called a maximum. So in this case, in terms of our max or our min, we have a maximum because the graph opens down. So the vertex is the highest point that we get. Now, if we had a U-shaped graph, so don't write this down, but if we had a U-shaped graph, then we would have a minimum because that would be the lowest point. The point at which it changes direction. So instead of decreasing, it changes direction here, and it turns to increasing, and it goes on forever. So the lowest this gets, this would be called a minimum. And so we kind of knew that because we know if it's a U-shaped graph or an N-shaped graph by looking at this. So if this number is negative, it opens down because it reflects over the x-axis. If it's positive, it opens up, so making a U-shaped graph, and that would give us a minimum in that case. Now, what is this maximum? What's the coordinate point? Well, that coordinate point is called the vertex. So that's what we're going to find. And how you find that is given A, B, and C, you plug in the formula opposite of B over 2A. Now, when we did the quadratic formula, remember how the quadratic formula starts. Opposite of B, and then it's this whole plus or minus, B squared minus 4AC, all over 2A. So that little left part of the graph, when we would simplify, that is the x value of your vertex. So when we find the vertex here, by using opposite of B over 2A, that's just going to give us the x value of that vertex, and then we'll have to plug it in to find the y value. So let's see what we have. So opposite of B. So here's what it's going to look like. B is a positive 8, so the opposite of that would be a negative 8. So we have negative 8 divided by 2 times A, and A is a negative 3. Okay, so we have negative 8 over 2 times negative 3 is negative 6. Now if I put that in my calculator, I reduce this. A negative divided by negative is positive, and 8 divided by 6 reduces to 4 over 3. Now this is just the x value. So what we're saying is that our vertex, or our maximum, is going to be 4 over 3, comma, something else. Well, I need to know what that is. And so that something else, I find out by plugging it into my calculator. And so what you are going to need to do is you're going to have to replace everywhere I have an x with 4 over 3. So in your calculator, you're going to say negative 3. I'm going to replace x with 4 over 3. So 4 over 3 squared, use parentheses, plus 8 times 4 over 3. Again, use parentheses because I'm replacing x with 4 over 3, plus 16. And as you plug that in using the square and the negatives and parentheses all in the right spots, I'm going to cheat here. You're going to get a vertex at 64 over 3. So when you plug that in and you hit math, enter, enter, your y value is 64 over 3. And so this is going to be your answer. So you hit math, enter, enter, you get 64 over 3. Meaning when x is 4 over 3, then y is 64 over 3. So you guys are going to have a graph that opens down, so an N-shaped graph, and it's going to have a maximum at 4 over 3, comma, 64 over 3. And that's all we have to do for today.